Alright, so for my interactive element, I have these worksheets for you guys to fill out as I go throughout my speech. So I'm going to do this one for you, and then Tyler, you already got yours.
Thank you.
You're welcome. So, what those worksheets discuss is 5 different points about the cosmological evidence for God. And what the cosmological evidence basically talks about is the beginning, and that's basically the word it encompasses. Now, the point is, because it's kind of like proving God is for the evidence. Now, here's the thing. If the universe is infinite, as many people, some still think it is, and some don't, but that used to be the leading theory, that the universe was infinite. Now, if it was infinite, then there wouldn't be a beginning, and therefore not a beginner. So what we're trying to prove here through the cosmological evidence is that there was a beginning, and if there is a beginning, then there would have to be a beginner. Just like everything has a cause, there's a causer, there's a beginning, there's a beginner. So that's what we're going to talk about. And number 1 on your worksheet, you guys can fill this out, is the philosophical evidence. And say you take it and you just have your hand, say you have like an infinite amount of handguns on a rack, kind of more example, but you have an infinite amount of handguns, right? And you take, say, 12 handguns off the rack. Technically, you subtracted a number from infinity. But the fraction of that infinity that you still have is infinity, even though you only took 12 handguns, yet there's still infinity on the rack, even though you subtracted a certain amount of infinity from it. You're probably confused, and you should be, because it doesn't make sense. So in mathematics, sometimes theoretical infinites make sense, but in our tangible universe, there's no such thing as infinites. It would be illogical to think of an infinite number of past time, of past minutes, hours, and days, because if there was an infinite number of the past, then we'd never get to the finish line that we call today. Make sense? An example of that is like a race. If you're at a starting line and ready for a race, and the guy with the gun, right before he shoots it off for you to go, he just tells you to scoot back 6 inches every time, and then he does it again, and right before you start, scoots back 6 inches. You'll never reach the finish line because you never started. And that's basically the whole deal here with the universe. If there was never a beginning, never a start, you'll never get to the end of today, the present time. Now, number two on the worksheet is theoretical evidence, right, and observational evidence. So you fill both those in. Now, in 1916, Albert Einstein applied his famous theory of relativity to the cosmos, and what that did is showed him that the universe was actually not static or not infinite, as many people have thought it was. It was actually expanding and or contracting. Now, Vesto Slipher, another American astronomer, actually studied spectrographs when it would measure like certain objects moving in or out of the universe. And he studied nebulae, which is just another fancy word for space material, as it was moving out of the universe, and he measured it, and it was actually red on the spectrograph, which means that it was going away from something, away from our universe, specifically. Now, Edwin Hubble, and I don't really know how to pronounce his name, but it's Monsignor Jorge Lemaitre, so I think it's German, but they both collaborated and discovered that space material was actually other universes and other stars that was moving away. And what they concluded was, since it's moving away from our universe, our world, it must have at one point been clustered together or closely tied together if it's moving away. So back to the point of that the universe is not static, it's in motion, so it's changing, so it couldn't be infinite. Number 3 is the thermal evidence. You guys can fill that one in. And that's specifically talking about the second law of thermodynamics. And the definition of that second law is the quantity of energy within a closed system, such as the universe, remains the same though the amount of usable energy deteriorates over time. So technically, the universe is considered a closed system, but since the energy is slowly decreasing over time, it could be logically assumed that it was at one point had a beginning, it had a start, or else how would you be able to measure the energy deteriorating if you didn't have a start point? Now, an example for that is like a wound-up toy car. You know, the cars that you pull back with the little wheels, and then you let go, and it goes, but the energy slowly deteriorates. Now, what one can see is that there is a point where the car starts before you let it go, and it runs out of energy. So kind of the same thing with the universe. If the energy is deteriorating, it has to have a start point to measure it from. Because if the universe was infinite, you can't measure an infinite number of deteriorating energy, because the universe's energy is infinitely deteriorating yet never completely deteriorated. So it's illogical. Now, number 4 is the residual evidence of the cosmic background radiation. So in 1964, there were 2 American physicists, one named Arno Penzias and Robert Wilson was the other one. And they discovered, actually accidentally, the background radiation from so-called the Big Bang. And they actually won a Nobel Prize for this because it was so important to science, because at that point, they believed that the universe was static and infinite and didn't need a beginning. So their discovery of that background radiation, it's kind of like a flashbang. You know, when you throw a flashbang in and then it detonates, the ones affected by the flashbang have a residual effect. It still lingers a little bit, like burning of the ears or slight blindness, temporary blindness for a little bit. And that's what the background radiation was. So if we're assuming there was a beginning, which we're talking about, that a rapid expansion from mass density and an insane amount of heat, we would expect to see some lingering effects, which we do, and that's what these 2 physicists discovered, which showed that there probably is a beginning. This was a tangible, evidential piece that started to freak out the atheists, because they're like, oh no, now we see that there's most likely a beginning to the universe, so there has to be a beginner. Now, the last one, quantitative evidence. According to stardate.org, hydrogen is the first most abundant element in the universe, but helium is the second. Now, what this astronomer, Sir Fred Hoyle, did is he thought the universe was static and infinite, so he wanted to test it. And he said, if the universe exploded into being rapidly, then obviously it would have to create helium. And ironically, a huge amount of density and rapid expansion from an explosion like that would create helium. That's the perfect environment for helium to form, such as we're saying as the Big Bang Theory. When it exploded like that, it created helium. Now, the amount of measurement that Sir Fred Hoyle measured actually exactly equaled the amount of helium that we have today in our universe, which another complete, tangible, quantitative piece of evidence that we can see that there had to be a beginning in the universe. It's quite insane how that worked out. But in conclusion, we have these 5 different pieces of evidence that are all scientific, but show these different ways in which you can have a cosmological evidence for God proving that there is a beginning, which would have to be a beginner. So for you guys, filling out the worksheets, number 1 real quick, what'd you get, Jacob? Number 1.
I got philosophical.
Perfect, thank you. So philosophical, just stating that theoretical infinites are possible in mathematics, but tangible infinites in the universe are quite illogical. You can't have an infinite number of past time. Now, Tyler, number 2.
Theoretical and observational.
Perfect.
Evidence.
So those are both just qualified together, talking about how the universe is not static, it's actually expanding and contrasting and changing, which means it can't be infinite. Andrew, for you, number 3, I think we're on.
Thermal?
Thermal, thank you. So the thermal evidence, that's the second law of thermodynamics, stating that the energy is slowly decreasing. It had to have a start point to measure the decrease from, and therefore it can't be infinitely decreasing and infinitely never changing in that same sense. The next one, Jacob, which is number 5.
Residual evidence?
Yes, residual evidence. Good job. So what that residual evidence is saying is that there is a cosmic background radiation, as you would expect from a rapid expansion of the beginning of the universe from a mass state of density and insane heat, and then we would see these lingering effects of that rapid expansion. Now, the last one is, Tyler?
Quantitative.
Perfect, and that's talking about helium, where we have the perfect amount of helium in our universe now as would have been created in the beginning of the universe, and not to mention that this rapid expansion of massive density and heat is a perfect environment for our second most abundant element, helium, to actually form. So what I want you guys to take away from this is that, tying it back to faith a little bit, our faith should be technically based on evidence too. And there's truth out there for the God that we believe in. So in essence, you guys need to focus on this truth and go tell other people the truth and the evidence about who God really is. Yeah.